This is 4.5. It's a two-part lesson on graphing the sine and cosine function. Here are some of our objectives. Don't need to write them down. All right, this first slide, I don't want you to write it down. I just want you to see the big picture. When we focused on the unit circle, we focused on the radius of 1. We found all those ordered pairs, and what those ordered pairs represent is help you to find the evaluation of a sine or cosine function. And you can go out and find the other 4 with those ordered pairs. So if we look at graphing this, looking at 1 revolution, which we will be doing later on in this lesson, that is 1 revolution. It has a distance of period of 2 pi and an amplitude of 1. Now we notice in section 4.4 that not all the time will we have a distance of 1 radius. Sometimes it could be square root of 161, or it could be 5. And so that will change in our graphs today. So we're going to start off with the parent function of the sine function, and the cosine function is going to look like this. There are many real-world problems out there besides just in our math class that why people have to know what a sine function and a cosine function do in the real world. So there'll be some modeling going on in part B, or part 2 of this lesson, of why we need to graph these out. So imagine there's infinitely many ordered pairs along here. We're going to show you some tools today to not have to graph every single ordered pair on our curves. So that's what's leading us to this slide. This is what I do want you to write down. This is what we call the parent function of the sine function. And we're going to just find 4 ordered pairs and graph those 4 ordered pairs. And the unit circle is going to help with it. This is the parent. Now there will be transformations, there will be reflections, there will be translations up and down. But if you know the basis of the parent function for the sine, those will be much easier to understand. So on the left-hand side is like a traditional XY chart where we would substitute an x into the function. In this case, they're going to be angles. In this case, radians. Radians is much more popular to graph in radian measure than in degree measure when we graph these sine and cosine functions. So this is my domain, and that is my range. So I'm starting off with thinking about the unit circle. If I remember the ordered pair for 0 degrees or 0 radians, what is the ordered pair on the unit circle? Do you remember? 0 degrees. The ordered pair is 1, 0. Which piece of that is the evaluation of the sine of 0 radians? 0. It's the y value. And that's why we had to know those. Then, if we go up to 90 degrees on the unit circle, or up to pi over 2, what is the coordinate there? Over 0, up 1. So the y value is 1. So the evaluation of the sine of pi over 2 is 1. Then we would go to pi. And I'm purposely picking 4 ordered pairs will help you later on. The sine of pi. The ordered pair there on the unit circle is -1, 0. So what is the evaluation of sine of pi? 0. Okay, we've got 2 more left. The sine of 3 pi over 2 down at 270 degrees. -1. And then the sine of 2 pi back to the starting point. 0. Okay, what we're going to do is we are going to graph this set of ordered pairs on an xy plane. Here's my x-axis, here's my y-axis, and I'm going to graph the ordered pairs. So the x-axis represents your angles, your domain, what you're substituting into the function, in this case, radian measure. The range is what you're getting out, which is your y-axis. So we already have up there 1 and -1. And then I'm going to start at 0, head over to 2 pi. And then I'm going to purposely split up every single time I graph sines and cosine functions into 4 equal parts. So we have pi, pi over 2, 3 pi over 2. Are there many more ordered pairs that we noticed on the unit circle? There was that 45-degree measure, or pi over 4, which had the ordered pair square root of 2 over 2, square root of 2 over 2. If we wanted to find more, we could, but we're going to just focus on 4. All right, 4 equal parts. So let's go and graph these. So the first sorted pair is 0, 0. The next sorted pair is over pi over 2, up 1. Then over pi, up 0. Then over 3 pi over 2, down 1. And then over 2 pi, up 0. So now we graph the curve. We go up, we go down, all the way down, and then back to where we started. That represents 1 revolution. The distance of that 1 revolution of the parent function is a distance of 2 pi, which we call the period in trig. So this distance from here to here is my period of 2 pi. Sometimes that will change. Sometimes it'll take longer for a revolution to occur. So it'll be a more stretched out wave. Or maybe it'll be shorter and it'll go quicker. It'll be a quicker revolution, like thinking about taking a rope and you want to like work it out in the gym. When you take that rope, a set of ropes, and you go like this, up and down, maybe you have a quicker, so your revolution will be faster. All right, this distance from here to here, the halfway in the height, think of it, this is what we call the amplitude. In the parent function, the amplitude is 1. So now I just have some questions for us to answer. In this parent function, what kind of numbers can I plug in for the domain? Any angle can work, right? Anything in the negative angles, anything in the positive angles. So all real numbers, from negative infinity to infinity. Remember, I only graph 1 revolution. This graph goes on forever. Talk about the range. On the parent function, what is the range? On the y-axis, what do you get out? From -1 to 1. Period. How long is the parent function for this period? 2 pi. Takes 2 pi, which is 6.28 radians. Amplitude on the parent function is what? Distance of 1, not 2, distance of 1. All right, there is the parent function for a sine function.